Okay, so again with this question, what is it saying? The mayor is interested in finding a 95% confidence for the mean number of pounds of trash per week that is generated in the city. So in other words, the mayor wants to figure out how much trash is generated per person per week in the city, right? How much trash are people generating? This mayor wants to do something about that. So he or she first wants to figure out how much trash is being generated. Now, hold on a second. Let's be real, because statistics is for application to real life, and people use it in the real world. So why would a mayor do this? I mean, what if the mayor wanted to know how much trash is being generated per person per week, how would the mayor find that out? Have you ever thought about that for a second? Stop for a second and think with me, because this is real life. Mayors and leaders, they need to answer questions like this. Doctors need to answer questions about a medical treatment and what percentage it's having an effect, etc. In real life, people need to answer questions like this, and statistics is a science that helps us answer questions like this. So real life here, how would the mayor answer this question if he or she needed to know this in order to make some wise policy decisions for the benefit of the city? Why couldn't the mayor just find out how much trash every person in the city generates this week and just do it that way? Why do we need some weird statistical confidence interval thing? Can't the mayor just survey every person in the city? Can't the mayor just survey every person in the city, find out how much trash, and find an average? It's easy, right?
They might not answer.
Yeah, good point, Vicente. A lot of people aren't interested in there's all these privacy issues, right? Yeah, they're not going to be wanting to tell how much trash they're generating. Not only that, even Vicente's point is a great one. For sure, he's right. And let's add to that, even if they were willing, like an online survey or something, the mayor is conducting an online survey this week. Please enter how much trash. Keep track of the trash and enter. Yeah, first off, almost nobody's gonna respond to that survey. And even if the mayor said, "Look, I'll pay you $1,000," if you'll respond to this survey, then I guess he'd get a lot of response. I'm not sure he'd always get the truth, but anyway, even if everybody wanted to respond to the survey, there would be all kinds of problems, right? First off, not everybody would see the email or the thing on the news or wherever you tried to advertise it. Tons of people aren't going to see it. Not everybody's connected to the internet all the time, and not everybody's looking at the same places, right? Just practically, real life, it just would be impossible to survey every person. Literally impossible, wouldn't it? There's just no way. There's just no way. Okay, and the same thing goes for medical treatments, for pretty much anything in life. When we want to figure out how a big thing is going, like the whole city and what kind of trash they're generating, or a new treatment for cancer and how all the patients that are getting that treatment are responding. It's hard to get a handle on these big kind of things. So the statistics, the science of understanding numbers in this way, what we do is we realize we can't do every person in the city, so we do small groups. It's impossible. It's impossible to do every person. So we survey a small group. That's why we're doing that all the time in statistics. And what we're going to see for the rest of this course, it's because practically speaking, real life, it's impossible to ask every person. No way it's going to happen. That's the same reason the pollsters do what they do, trying to figure out how the national election is going to go in November. You can't ask everybody in the nation ahead of time. It's impossible. So you survey, you ask a small group, and you hope that your results from your small group tell you something about what's happening for the whole group. That and that hope, like, how sure is that hope? Is that likely to be accurate? How likely? Well, that is the whole science of statistics. How do we know that our little small group survey is going to tell us the truth? Well, that's exactly what we're doing with our calculator, with these confidence intervals, with all this probability we studied. That's where the science of statistics comes in. That's why we're doing what we're doing. You can never be 100% sure. Why? Because you might have got a weird small group. You might have accidentally got a group of people who all produce a lot of trash, or maybe hardly any trash, whatever. You might have got an extreme group, extreme high in trash or extreme low in trash. Who knows? That's possible, but it's not likely, right? If you do it randomly, you randomly ask people all around the city, probably you'll get a pretty good picture of the truth. What do I mean by probably? Well, whoops, I'm sorry, guys. I just moved it. There we go. Probably you'll get a pretty good picture of the truth. Hold on. I'm sorry. I went to the wrong thing. Let me grab it for you again. Sorry, lecture, homework. Oh, sorry, here, I'll grab it for you again. Okay, sorry, we're back. All right, there it is. So probably, and what does probably mean? 95% confident, right? We want to become 95% confident. All right, I'm going on and on and on, but I really want you to understand the big picture of what a confidence interval is. Let's actually do it now. How do you do it? We're going to use our calculator, right? Let me go back. I'm going to need to grab this picture again because I moved everything around. So we're going to go to our notes, our exam 3 notes, and it's right here. Here it is, exam 3 notes, confidence intervals. And so specifically today we're doing mean. So earlier in section 8.1 we did P. Now in 8.2 we're doing mean. So this is for section 8.2, confidence intervals. So there was P here, it's mean today for 8.2. So right now we're going to start with the no data given. On some of the other problems we'll have data given, we'll see those. So we're right here in the notes. So exam 3 notes, as it says up here, we're on the mean. So the exam 3 notes are right on the Canvas module. You can find the exam 3 notes on the unit 3 module right at the top. That's where you find these exam 3 notes. So we're looking at the mean, no data given. So what are we going to do? We're going to do right here a T interval. So the first question that the homework system is going to ask you, the answer will be a T distribution. T distribution. Where am I getting that? From the exam 3 notes. We're doing mean. Did you see mean in the words? Right there, it says the mean number of trash per person. The mean number of pounds of trash per person per week was 33.7. That's the mean, the average, right? Mean is average. So the average person in the 196 residents, so they did a random survey. There's the small group, like I was talking about. They surveyed, they randomly went around the city, had the mayor sent out a group to randomly cruise around the city and ask people to try to get a feel for what the whole city's doing. They randomly asked 196 people, and the average, the mean for that group of people was 33.7 pounds. And the standard deviation, remember, that's how much variation there was, deviation. That's the average distance from the middle. right? Because not everybody was exactly right on 33.7 pounds. That was the middle, that was the average, but how far were they off of that? Typically by 8.5 pounds. They were higher or lower on average by 8.5 pounds. So we want to use that survey to help us predict what the average might be for the whole city. And we want to be 95% sure, confident, that we capture the real average. Just like when we were playing the game and I let you pick 50 numbers or 70, an interval of 70 numbers, that made you more sure that you captured my real number that I'd written down on the paper. That's exactly what we're doing with the confidence interval. We want to become sure, 95% sure, that we've captured the real average for the city based on our little survey of 196 people. All right, so the first thing we do is t-distribution. You get that right from here. Mean t-interval, t-distribution. All right, back in 8.1, remember it was a z-interval. It was z back in 8.1, but now in 8.2, it's t. All right, back up to it. We're going to choose t-distribution. Now it says, find your 95% confidence interval. All right, let's do it. How do we actually do our 95% confidence interval? Well, looking down at the exam notes again, we're going to go to our calculator and we're going to choose the t. We're going to go to the t interval and choose stats. T interval and choose stats. So let me write it out for you and then I'll show it on the actual calculator. In fact, let me just put in a page to show it right here. So, maybe better just put it right here. All right, so I'll do it right here for you. What are we going to do first? Well, first you got to push the buttons, the stat button. Here it is on the TI calculator. So you got to push the stat button and you got to go over twice to the tests and choose that. And then you've got to go down to just go down one to the t-test. No, I'm sorry, not the t-test, the t-interval. So it's not down one, it's all the way down to number 8. T-interval, which is what it says right here. I'm just going by the exam notes. See, it says t-interval. And then choose stats. So t-interval and choose stats. So go all the way down to t-interval. Hit enter, which is number 8. It's way down on number 8. Hit interval, and now you've got to move over. There's two options there, data and stats. You want to choose stats. We'll do data in a little bit. You want to choose stats and hit enter. And then it'll ask you for X bar, S sub X, N, and C level, confidence level. All right, so we're going to put in the X bar. X bar is the average. That's the 33.7. It's that average they gave you. That's what X bar means. The bar over X means average. S sub X, that's the standard deviation, which was 8.5. N is always the number of people they surveyed. That's 196 people in my example. And the confidence level, that's 0.95. We want to be 95% sure we're getting the real deal here. So I'm going to put that same information in my calculator. And then hit enter to calculate it. And the numbers I'm getting, they want you to round to 3 decimal places. Here's my answer. I got 32.503.
Mr. Herring?
Question?
Yeah, mine says input list frequency and then sea level.
Okay, I think you chose data instead of stats. I'll show in just a second. I'll show it on my screen. So, so here's the answer I got, 32.503 to 34.897. There's the two answers I got. Let me show on the actual screen what I just what I just did. So on my actual calculator, I mean. So let me go there and fire up my TI calculator thing. There it is. Okay, so let me view the key press history. Yeah, so first you push stat, go over to tests, go down to number 8, which is T interval. Hit enter. Now right here, here's where you've got to move. You can't leave it on data. See, on data, it has this kind of information. We don't want that. You have to go over to stats and hit enter. Everybody see what I did there? I moved over to stats and I hit enter. And then we go down. X bar, that was the, whatever it was, 33.7 for mine. 0.7. And the S sub X for me was 8.5. 8.5. And the N, how many people in the survey? 196 were in the survey. Confidence level, it's already at 0.95. That's great. I'll go down to calculate, enter. It's working. There it is. 32.503 to 34.897. It's already rounded to 3 decimal places for us. So there we go. I'll switch back.
Professor, I have a quick question. What website are you using to get your TI-84 calculator? Because mine just died.
Oh yeah, I have I can't it doesn't work normally. You have to have a special file to do it that they don't publish out there anymore. Yeah, so I would encourage you use your if you just go on your phone and type in TI-84 emulator, TI-84 emulator, you'll something will usually pop up. Students were able to just on your phone type in TI-84 emulator, and using your phone you'll be able to get one. But yeah, make sure you get it fixed or a new battery or whatever by test time, because on the test you can't use other websites or your phone. So make sure for the test. All right, so we good there? Any other questions on? Oh, we got to answer these last two, don't we? Is that working okay on the calculator? Is that you guys able to get the 2 numbers or whatever your 2 numbers are? Let's come on down and answer these last 2 questions. These will actually be pretty easy. It says if many groups of 196 randomly selected members are studied, then a different confidence interval would be produced for each group, right? If we kept doing this again and again and again, right? You tracking with the question, right? We asked 196 people how much trash, and the average for that group was 33.7 pounds. And we formed a confidence interval that made us 95% confident that the real average, right? Do you understand what that confidence interval means? I hope this is really clear after all of our lead-in. We are 95% confident of what? That the true average for the whole city, is in the interval, right? We are 95% confident that the real average, that the true average for the whole city is somewhere between 32.5 and 34.8. That's what we're saying. It's somewhere between 32.503 and 34.897. We are 95% confident. We're pretty sure that, so this kind of information would be helpful to the mayor. He or she would be able to look at that and go, okay, so it looks like on average, somewhere between 32.5 and 34.897. We're 95% confident that the real average is somewhere in that interval. That's pretty good results. That's pretty confident results on that. So then the question is, if they kept doing this again and again and asking 196 different people, blah, blah, about what percent of these confidence intervals will contain the true mean? What percentage, in other words, what percentage of the time will you get it right? What percentage of the time will you capture the true value?
95.
Exactly. I hope that makes sense. Yeah. They're just asking to make sure you understand that we're 95% sure we captured the real value. So that means 95% of the time that you do this kind of study, asking 196 people, 95% of the time you're going to capture the real value. And then down here it says, what percent will not capture the real value? Will not. So the second and last question, what percent will not contain the true value?
The 5%.
5%, exactly. That's like if there's a 95% chance of rain, and there's a 5% chance it won't rain. If there's a 95% chance we captured the real value, there's a 5% chance we won't. So 5% of the time you do this, you won't capture the real value. 95% of the time you will.